All right. Well, I hope that everybody's having a good day and ready to have a good weekend. Just a little announcement to make sure we know what's going to be happening in the coming week. We already talked about what's going to be happening today. So Monday, I'm not going to be here. I've got an appointment that I need to go to, so I'm just out the entire day. I am going to be leaving you another little collection of problems, just like I did earlier in the week, but this one's going to be covering correlation coefficient and linear regression. These are problems that have appeared on past paper exams. So absolutely a really good idea to go ahead and take a look at those, and then we can discuss them when I get back on Tuesday. But the plan is to finish talking about Spearman's correlation coefficient, hopefully by Tuesday. Now on Tuesday, we are going to have a quiz over linear regression. Okay. Then Thursday, we'll have a quiz over Spearman's. We'll turn the homework in. When did I say that? The assignment for Spearman's is going to be due on Wednesday, and I actually have a copy of it right here that I can pass out before you folks take off. And then we'll have a quiz over it on Thursday. Later in the week, we'll go ahead and look at normal distribution, and then we'll just go from there. We'll just continue through this. We don't have too much more stats left. We got to talk about chi-squared test for independence. We got to talk about chi-squared goodness of fit. And I think that might be the tail end of our statistical unit. Then we can go ahead and start getting into logic, probability, and sets and all that good stuff. All right, so any questions about any of that? Okay, well, let's go ahead and take a look. So the linear regression assignment is due today. Okay, so there's the notes. Okay. And then here are the two questions. All right. Were there any of these that we wanted to go ahead and take a look at? 1D. Okay, so find the equation of the line of best fit.
So again, only students that have tickets, those are the only ones released from class. Again, we'll have football on today's date and homecoming. So please release them. Freshmen, you go into the gym, and sophomores go to the right. Juniors and seniors go to the left. Again, that's once you're in the gym. Thanks, guys. Also, make sure to leave your backpacks. If you do bring your backpacks, you'll have to leave them outside. Thank you.
Okay, so Justine, you're asking about this, so I'll continue to work the problem. You just want 1D?
Yes.
Okay, and then I'll have this posted later, so you can go ahead and take a look at it, and you've got your ticket.
I turned it in on Tuesday. My calculator died.
Oh, that's fine. That's fine. No problem. Okay, so let's go ahead and do this. And Justine, would you shut that door for me, please, ma'am? Thank you so much. All right. So the problem states that a newspaper reports starting salaries for recently graduated university students, which depend on whether they hold a bachelor degree or a PhD. All right. And then the amount that they're going to make based on whichever they have. So we could go ahead and draw a scatter diagram, determine R, describe the association. So we can actually run through these pretty quickly because all of it is just a few keystrokes away once we put all the values in. So I don't have this paper in front of me, so I'm going to rely on you folks to help me out in putting these data elements. Okay, so let me go home, new document, lists and spreadsheets. Okay, so that I believe was the bachelor's, and then Y we'll just say is the PhD. Okay, can somebody tell me what the first column of data is? Anybody have the paper? Oh. 38250. Okay. 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 And let's go back up. Okay. Okay. So I got everything in. So let's go ahead and determine what the correlation coefficient is going to be. Now this is Pearson's. So I'm going to go to menu, statistics, stat calculations. Okay. So I'm going to backspace there. So the first column, that represents the bachelor's degree. Second column is the PhDs. Okay. Don't worry about this. It's going to appear in, if it'll show it. There we go. Column D, let me go ahead and click OK. And here we go. Okay, so it looks like R is 0.92. So one of the things it wanted us to do here, where is it? Okay, we determined R using technology, describe the association between starting salaries. So 0.92, how would you describe that? Okay, very strong, and I go ahead and say positive. Yeah, there you go. Strong positive. All right, what else do they want? Find the equation of the line of best fit. So now we're going to go ahead and do this at the same time we do A. So I'm going to come on back over here to my calculator. So I'm going to go home. Now we want to come down here to data and statistics. Okay, the one that has the icon of this histogram right here. It's just going to go ahead and throw all those points up there. So I'm going to click tab. All right. Looks like I have quite a bit extra, but I'm just going to put in the 2 column headings that I had right there. And then I'm going to hit tab again. Let's choose Y. Okay, so it's definitely a positive correlation. Now, how did I go ahead and have the calculator not only put in the line of best fit, but predict the equation? Menu, analyze, regression, and then show linear, mx plus b. Okay, so I'd say we're looking at about 3.44x minus 78,255. Let's see if I can, and then 0.5. Okay. You know, if it doesn't say, typically I'd go ahead and run with 3 sig figs. That's typically what IB likes. Otherwise, they'll specifically tell you the number of sig figs, or they'll tell you the decimal place they'd like you to round it to. So this one here, what was it? 3.44x. Sorry. Okay. So y is equal to 3.44x, and then it was minus, and it was a 70,000 number, 78,255. 78,255.5. So there's my prediction equation. And it says, we might as well just go ahead and finish it up. The starting salary for an economist with a bachelor's degree is $40,000. Predict the starting salary for an economist with a PhD. So what am I going to do here? Like, what are they providing me with this value? An X, the way we've labeled them. So I just want to go ahead and take this and plug it in here and then see what our predicted amount is going to turn out to. So 3.44, and it's 40,000. Okay, so let's go back home. So 3.44 times the 40,000. Okay, and then it was minus 78,000. What was it? 555.5. Okay, 555, 255. Sorry, 255.5. Okay. So based on my prediction equation, it looks like an economist with a bachelor's degree, with a PhD, excuse me, is going to end up with $59,344.50. But now let's comment on the reliability of this. Remember, one of the things we talked about the other day, there were 2 key words. Okay. Do you remember those 2 long key words that I brought up the other day? One starts with the E, one starts with the I. Extrapolation and interpolation. Okay, what's the difference between the 2? Like, what does it mean, extrapolation? There you go. It's outside the data set, right? So this value of x they gave me, well, let's see, is there anything in this list right here for the x's, anything less than 40,000? Yeah, definitely. We have 38,250 right there. Oh, 32,750 right there. And is there anything that's higher than 40,000? Definitely. So I would go ahead and say this is an interpolation. Because the value that we're asking about is contained within the range of values for the bachelor's degree, I would say this is pretty reliable. We got a correlation coefficient that was pretty strong and positive, so I would think that that's a pretty decent prediction. Now, if it were to ask you if a bachelor's degree for some kind of field is going to earn $50,000, would it be reasonable to go ahead and use the equation to find a PhD from the same field to see what he or she would earn? No. That's when you have an extrapolation. The interpolation is when your data value is within the range. The extrapolation is when it is not. Okay, good. All right. Did we want to do number 2? Jason, you want to do it? Sure, why not? Hey, we're going to go a whole weekend maybe without math, so we got to make sure we got it. Yeah. Unless you have that weird craving like I do on Saturday night, just I got to do some math. Surely I'm not the only one, right? Amar shaking his head. Yes. Okay. Gotcha. All right. Let's take a look at number 2. Steve wanted to see whether there was any relationship between the temperature when he leaves for work in the morning and the time it takes to get to work. He collected data over a 14-day period. Okay, so draw a scatter diagram. We can do that with the technology R as well. Describe the relationship, and is it reasonable to try to find a line of best fit for this data? Okay, so everything is going to be dependent on what the technology results are going to be. Okay, so let me come on back here to, now I'm going to document B out of this, but when I come back over here to current, I want to go ahead and erase that. So Control W, no, I don't want to save it. Okay, so new document, list and spreadsheets. Okay, there's X again. As always, we're going to avoid this equals row. And again, somebody, if you could tell me the 28 elements. What are the 14 temperatures? Okay, now let's put in the corresponding values. That was weird. Okay. Oh, I'll just do it that way. Okay, and the second column of data, the second row. 59? 39, sorry. Okay, thank you, bye. All right, so we have our data. Let's go ahead and run through our keystrokes, statistics, stat calculations, 2 variable, right, because we're comparing 2 sets of data. This is bivariate, how you say that? Okay, the first one here, this is the title of my first column. This is the title of my second column. Let's ignore that, column D. Okay, and here is R right here. So it's a negative, let's say 0.22. So how would you describe that? I'd say weak negative correlation. Okay. So, yes. Oh, like weak, moderate, strong? Yeah, I just, so I thought I remembered, like 0.25 and below peak no correlation. Is that what the data said? It might have been. Let's. My baby. Oh, that was yours. Okay. I mean, I'm still worried about it, but okay. Let's go back over here because I think you might be right, Robin. Let's see. It was. You're absolutely right. No linear relationship. Yes. Okay. So we can go ahead and conclude there's no linear relationship here. So let's go ahead and just run through the rest of it anyway. They wanted to go ahead and see the scatter plot. Okay, so I'm going to go back home. Okay, data and statistics, all these points, tab. Always do the horizontal first. Tab what? Is there a reason for what? Just because you don't want it inverted. So yeah, definitely looking at this scatter plot, I mean, they are pretty far apart. So I can definitely see why it's so weak. I mean, even knowing this, I mean, let's go ahead and just practice finding the equation, analyze regression, because I'm kind of interested to see where the computer feels that it would best fit. Okay. So negative 0.22x plus 44.72. So one of the last things it wants us to do on this paper Okay. Is it reasonable to try to find a line of best fit for this data? No. I mean, the only reason I did it here was just, again, to go through the keystrokes, make sure that everybody was okay. From our inequalities, as Robin said, yeah, there is no correlation here. The scatter plot proves that. So I think that's good. All right. Questions? So how are we doing? So come Tuesday, we'll be ready for that linear regression quiz. Fantastic, fantastic. Okay, well, let me go ahead, get rid of this. Let's go ahead and do one more Spearman's. Okay, so Spearman's rank correlation coefficient. So any scatter plot that could be modeled by a linear function, by a linear model, you're going to want to go ahead and use Pearson's. But if a linear model would not be appropriate at all, that's when you're going to go ahead and use Spearman's rank correlation coefficient. So you're not using the data itself, you're using the rank of the elements to go ahead and determine what that is, R sub S, by this formula. 1 minus 6 times the sum of the different squared column divided by n times n squared minus 1, where n is the number of terms. Okay, so let's try another one of these here. We already talked about this, a drawback, losing the data. The benefit, it is easier to calculate than Pearson's. You don't have to run through that entire table, especially if you're doing it by hand. Okay, so let's try this one. This problem number 2 says, Table 1 shows 7 countries selected at random, their HDI, Human Development Index, a measure of their quality of life, and their GNP, Gross National Product per person, a measure of their wealth. Okay, so Table 2 shows the countries are ranked in descending order from their HDI. And remember, this is how we did it yesterday. You want to rank the data from the largest to the smallest in descending order. So if you take a look at their HDI here and then compare it to what they have here, the first one that's listed, 0.97, that is the highest. Okay, so this one actually does go 7, 6, 5, 4, 3, 2, 1. Okay, so actually it is in ascending order. So let's go ahead and do this with the GNP. So look at all the elements for the GNP. Okay, 20, 26, 25, 93, 22, 66, and 113. Which one's the biggest? Okay, the 113, so that's going to be a 1 right there. Okay, then next highest. Okay, is it Oman? Oman? I'm not sure how to say that. Okay. Oh, man. Okay. I am not making fun of it. I'm a very punny guy. Okay, so, all right. So that's 2. What would be 3? Cuba, so that's 3. That's the next highest. Then we would have Rwanda, so that would be 4. India with 5. Then we'd have China, that's 6. And then Niger that would be 7. Okay. All right. So once you've rewritten or numbered, I should say, ranked the data in order from the largest to the smallest, descending order. So now there's only 2 other things that we need to go ahead and do. We're going to find the difference of those ranks, and then we're going to square that difference. So 7 minus 7, 0, 6 minus 4, 5 minus 5, 4 minus 2, 3 minus 6, 2 minus 3, and then 1 minus 1. Now, what was the way of checking that if you're actually on the right track, if you're doing everything correctly? Yeah, the sum of the differences should be 0. So let's say 2 plus 2 minus 3 minus 1. Yeah, that sum does equal 0, so we're good to go. So now let's go ahead and square all those differences. So 0 squared, 2 squared, 0 squared, 2 squared, negative 3 squared, negative 1 squared, and then 0. So we do need that sum. 18. Okay, so 18. So I'm going to go ahead and use that sum to help me out. Let's go ahead and write down the formula again. Okay, so remember, we saw it for the first time yesterday. 1 minus 6 times the sum of the square differences divided by n times n squared minus 1. So I'll go ahead and write down that formula again. R sub s equals 1 minus 6 times the sum of the square differences divided by, and I'm not really sure why they do it this way, because what's another way to write n times n squared minus 1? You could just say n cubed minus n. I don't know, maybe breaking it up makes it a little easier. Okay, what do you guys think? Yeah, maybe. Okay. All right, so let's plug in everything. 1 minus, we have 6 times. Well, the sum of the difference column was 18 divided by. How many terms did we have here? We have 7. Okay, we were dealing with 7 countries. So if n equals 7, that would be 7 times, now 7 squared, 49 minus 1, 48. Would everybody agree?
Yes.
Okay, now it's just a matter of plugging it in and seeing what we get. Let's get out of here. So 1 minus control divide. There we go. So 6 times 18 over parentheses. It was 7 times 48. Is that right? Okay. So what should I be getting when I push enter? 1928. So of course I got to hit control enter. So let's say about 0.68. Okay. So R sub S is about 0.68. Okay. All right. So how would you describe this? I'd say moderate, positive or negative? Definitely moderately positive. How would you interpret your answer to part B? Like how would you write what you're thinking in a complete sentence? Now remember, we're talking about the rankings of these countries comparing their HDI and their GNP.
Countries with higher HDI tend to have higher GNP.
Okay. All right. Okay. There seems to be evidence that from the rankings of the two quantities, the higher the HDI, the higher the GNP. Okay. All right. And that's it. I mean, that really is Spearman's. The only other thing I can show you, have you noticed anything about your data yet? What can data do that we've actually seen quite often that these sets have not? Remember, we're ranking them, so what could potentially be a problem if we're trying to rank the data? Not outliers. What if a data element repeats? Okay, so that's the only other new topic that we're going to go ahead and talk about come Tuesday. All right, so I just wanted to go ahead and show you another problem. Go ahead and discuss it. Does anybody have any questions? All right, fantastic. Well, with